I'm going to start explaining. I'm going to explain what beta testing actually is. So beta testing is a process of where we review software that, in our case, WPILib provides us work with. And our job as beta testers is to document or suggest any improvements to provided documentation for software. We report these through task reports that are given through us that are available in TeamForge accounts, which beta testing teams have to sign up for. So the installation processing includes TeamForge. So you sign in through TeamForge and then you download the WPI installer for either or both Java, C++, or LabVIEW. The FRC game tools like DriverStation, Shuffleboard. There's also new CTRE and Rev libraries like third-party libraries for motor controls and other sorts. There's also new beta versions of the Rio images for flashing the new Rio to the new version. And like I previously mentioned, there's discussion forums and task reports that allow you to communicate with the WPILib team to tell them your results and your experience working with their new software. So a general overview of changes, can be found with the first. Can you guys see the first link or no? It's this presentation bases the changes off of this link, and the second and third link. You guys can't really see the third link, but the second link is basically the beta documentation for Java, and the third link is the beta documentation for C++. Out of curiosity, how many teams here use C++? All right, so that's fine. So if you guys want to follow this change list as we go along, you guys can use that tinyurl.com/FRC-2022. So the major changes in this change log are drive class functions no longer invert the right sides by default. So you have to invert either the right or left side. I think it's the right side with the set inverted command. There's also removals of old templates that were deprecated in previous years. So VS Code removed old command-based template, and you have to use new command-based template now. And similarly, the iterative robot template has been removed and replaced with time robot. The general library changes. Network tables now have support for Mechanism 2D. There's a time slice robot template along with the other templates that were added to this year. There's a C++ tank drive example that has been added. There's a PS4 controller class that has been added, so you don't have to use Logitech controllers or Xbox 360 controllers. There's a debalancer class for both Java and C++. There's also a pneumatics hub class for use with Rev pneumatics hub, as opposed to, I think, CTRE. I forgot, but I think there's CTRE and something else. The Xbox controller class no longer takes arguments, so they have standalone methods that you can use. So an example would be control that get trigger access, and instead of taking an argument, which would be the left hand, you just get you can retrieve the left hand by just using get left trigger access. Get instance methods in camera server, driver station, live window, preferences, and sendable registry have been deprecated and replaced with static functions. And for C++, timer has period passed, and for Java, timer has period passed has been deprecated, and you would use instead advanced if elapsed. The breaking changes, there are a lot of them, I think. So power distribution panel has been renamed to just power distribution, and classes that utilize pneumatics control hub like solenoid or compressor, they now require you to specify what type of vendor provided the solenoid compressor. So the new constructor would take, the old constructor would just take the port or channel that uses that for the specific motor. This year or next year, or for the oncoming years, they've changed it to take either a pneumatics module type. It looks really blurry, but in addition to the port, you need to provide a module type, which is either a CTRE one or a Rev one. So yeah. Sendable has been split into network cable and non-network cable components to make it easier for third-party libraries to integrate Sendable. Interruptible Sendable base has been split into asynchronous interrupt and synchronous interrupt, and they should be passed rather than extend digital input. Speed controller has been renamed to motor controller and has been moved to like a dot motor controller package. And I think the methods for speed controller have been like more simplified. So instead of set speed, there's just set, and set disabled, there's disabled. A bunch of methods have been removed and moved to the PWM class. And also various driver station in mode functions have been renamed. So like in disabled has been, so it's from Pascal casing to camel casing. And this would be the same for like in enabled and in, yeah, for in enabled. Previous years, I think 2020, like Geartooth was from, they deprecated Geartooth back in 2020, so now they finally removed a bunch of the deprecated material. So WPILib camera server has been moved to just camera server, and then yeah, a bunch of these. Robot drive has been removed, replaced with differential drive and Geartooth. So for C++, I'll just go over them. Driver station.report warning and driver station.report error have been removed and replaced with FRC underscore report error. Sorry, what?
I think you can skip the C++ slide if it's not under.
Yeah, okay. These two. Some package renames. WPILibJ, some of the packages have been migrated to math, so like controller, estimator, geometry, kinematics, math, spline, system, and trajectory. And WPIUtil.math has been moved to math, and WPIUtil is now just util. Slew rate limiter, linear filter, and median filter have been moved to math.filters. Timer has been moved from FRC2 to just FRC. And like mentioned before, motor controllers have been moved to a motor controller package. And edu.wpi.cscore has been moved to edu.wpi.first.csc score. Some miscellaneous changes. There have been ease of use changes for shuffleboard. They fixed issues with some camera server streams and added a field 2D widget. The Gradle Rio version has been bumped up to 7.2. There's also been ease of use changes, and deployment is now more customizable. For C-Score, the OpenC version has been updated to OpenC v4. Outline Viewer has discontinued the Java version, so it's based off of C++ now. For VS Code, there's a project importer for the 2022 season, which will only import 2020 or 2021 projects. And the Eclipse project importer has been removed. For Route Builder, C++ type detection has been improved, and some imports have been fixed. So the new, so there are some new or heavily modified features with this beta. One of these features is sysid. So sysid is a way of like characterizing your motors, your drivetrains, your arms, and elevators. It replaces FRC characterization, which has been discontinued, and there's a new interface. There's a new interface with graphing analytics and RAMI integration. Yeah. I actually have a Rami here, so if you guys want to pass this around. So characterization basically is characterization is the process of mathematically modeling the behavior of a system. So you can, for FRC, you can use this to find your PID constants, your required input voltages to find a specific output, and yeah. And then the other feature that's been added, I think, yeah, the only other feature that has been added is Axon, which is a machine learning based computer vision system, which I think is really interesting. It's an alternative to Limelight and like other like cameras, and you can train it to detect a generic object or like basically any object that you want to detect, and it will provide like predictions like how far away you are from the object. And to set that up, I think, yeah, so you need to install the Axon launcher, which is provided on the WPI GitHub. You need to install the Docker app, which I think handles all the dependencies that come with machine learning. And Supervisely is an online website where you can upload your video of the object you're trying to like to detect, yeah. And after all that, you can test it by uploading a dataset file into the web interface of, say, something like WPILib Pi, which is for Raspberry Pis. And for robots, the data is sent over in a JSON string to the network cable entry for machine learning. Yeah. So how you would do this is you record a 1 to 5 minute video of your object that you're trying to detect, and then you upload it to Supervisely to create a data set. Or you can use, Google has an open data set that has tons of pictures of generic objects. Like, I think there's like cats, dogs, like anything that you want. So you can use that instead to train the neural network to detect what object you're trying to do. So Axon, I think it's best if I just demonstrate it. Here. This is Axon. Actually, I need to open the Docker first. Right. So you would click Run Axon. All this is on the WPILib GitHub, so you can just download from there. Right, and then it would open a browser screen. And hold on, it's loading. Yeah, so if you have a custom object that you want to detect, you just upload your dataset, which I don't have, that you get from Supervisely. Yeah, so you can create a free account, and then you would import your video here. And then with this website, you can label your image and then send that data set to this Axon launcher, which will train the neural network that WPILib has provided for us. And then, yeah, you can train it to provide to create a test model. And if you're like inferencing it or testing it on a WPILib Pi, you can upload it to the network provided by the Rami or the robot, the Raspberry Pi. And then you can upload it on the website, and then they give you a Python script that you can run in addition to this that will provide like in real-time data. So it's an alternative to like Limelight or other reflective tape and camera systems like that. And yeah, I have a little demo using sysid right now. So this is what sysid looks like. So you would put your team number. It works for any general mechanism or drivetrain, but I'm going to try doing it with the Rami right now. Actually, yeah. So then you would choose your analysis type here. So drivetrain or general mechanisms like arms and like grabbers and stuff. You would turn the logger to client, and then you can type in your team number. And these are the 4 tests that you can run. I don't know if you guys can't see it, but there's 4 tests that you can run, and after running each test, you can save a file, and then you can use that you can analyze that file using this app or this program to find your constants, like for PID or motor input voltage constants. And they also give you a nice graph, but I can't seem to move this on the screen. Yeah. Wait, where's the Rami right now? So sysid has built-in integration for Ramis. I'm going to try to do a little demo. So I have a test project for this Rami, and wait for it to show up. Okay. All right, and then this is you can go to this, the IP that the Raspberry Pi has been attributed to. So in this case, it's 10.696.94. And you can see like the status of it and like the battery life, or not battery life, the battery voltage, the version of firmware it's running. You can also connect a camera to it to utilize like Axon and other camera systems. So for sysid, to show this. Okay. So you would simulate robot code. And what this does, it isn't actually deploying any code to the Rami. It's doing all the calculations and stuff on this laptop or this computer, and it sends it to the Rami. So, yeah. This is sysid, and then they give you trackers with a gyro, which seem to flash. I don't know why it's not opening. Yeah, and then you can run autonomous procedures on it. Yeah. Or you can run the teleop procedure, which is, in this case it just drives forward. But it's not driving forward. Hold on. Let me restart this. Yeah. So we just drive forward. Okay, so that's basically it for this season's beta testing. Are there any questions? All right, well, I guess thank you for coming to my presentation. Enjoy the rest of the slide.